In this video, I'm going to be talking to you about scientific notation. So let's go ahead and get started. So go ahead and find 5 to the 20th power on your calculator. Now, depending on which one you're using, if you're using the one recommended for Math 1332, you're going to get that. So 9.53 and all those numbers times 10 to the 13th power. So this is a very big number. Basically, 10 to the 13th power is a 1 with 13 zeros. And like if you had a graphing calculator, you might get something like that. Or there are some scientific calculators that'll give you a different form, but they're all the same number. Let's move on to the next slide here. So scientific notation is used to represent very large or very small numbers. So numbers in scientific notation have the following form. Here's an example. 3.5 times 10 to the 4th power. The first number is going to be a number between 1 and 10, not including 10. Or the other way to think of it is, it's a number that has one digit left of the decimal. One digit left of the decimal. The other number is going to be a power of 10. Alright, let's move on. So there's a nice pattern that we can use to convert numbers back and forth between scientific notation and our standard notation, which is also known as decimal notation. So if you multiplied 4.23 by 10, you can do that a number of ways, but you would get 42.3. If you multiplied by 4.23 times 10 squared, 10 squared is 100. 100 times 4.23, you get 423. If you multiplied 4.23 times 10 cubed, that would be 1,000 times 4.23, and you would get 4,230. So if you look at this pattern here, you can see what's happening. Basically, we have 4.23. Notice if I put a 0 in here and I move the decimal 3 to the right, we get the 4,230. So basically our exponents here are telling us how much to move the decimal to the right. We're multiplying by powers of 10, so our number will get bigger, and so we're going to be moving our decimal to the right the number of times indicated by the exponent. Alright, let's move on. So now you should be able to find 4.23 times 10 to the 6th power. So we're going to write 4.23. We're going to need to put some zeros in. Put a bunch in, and just enough so that when we move 6 places to the right, we're going to be okay. So I'm going to go ahead and move 6 to the right. That puts me right there. So I always count the number of zeros. I'm going to have 423 with 4 zeros. And so there's 423 with 4 zeros. That's 4,230,000. All right. Now if we had 4.23 times 10 to the 0 power, you could actually put that in your calculator. You get 4.23. I would just remind you that anything to the 0 power is actually 1. And so multiplying by 10 to the 0 power doesn't change anything. But let's move to a negative exponent. So what if we had 4.23 times 10 to the negative 1? Now if you look up above, when we had 10 to the 1st power, we moved 1 decimal to the right. Let's see what happens here. If you actually multiply by 10 to the negative 1, you can do that on your calculator if you want. You're really multiplying by a tenth. That's what 10 to the negative 1 power is actually equal to. And it has the effect of moving the decimal the other direction. Notice we went from here to there. So let's do it again. 4.23 times 10 to the negative 2. Again, if you put this in your calculator, you get 0.0423. But again, you can see that if I put a 0 in here, I basically went 2 to the left. And so that's how we're getting our answers here. So go ahead and find 4.23 times 10 to the negative 7 power. You might want to stop the video. All right, and so we would write 4.23. We know we're going to go to the left 7 times, so we're going to need some zeros. Let's go ahead and move our decimal 7 places to the left. And again, I like to count zeros. I got 1, 2, 3, 4, 5, 6 zeros, and then 423. So be careful that you count your zeros correctly and that you put the right number of zeros in. All right, so let's go ahead and practice this. So again, you're going to have to be able to convert both directions. So we'll start by converting to decimal notation if I give you scientific notation. So the first problem here is 3.56 times 10 to the 5th. So if you think you understand, go ahead and try the problem and then watch the video. All right, so we're going to take 3.56, multiplying by 10 to the 5th, we're going to get bigger, so we're going to move the decimal 5 places to the right. So let's put some zeros in and move our decimal 5 to the right. And so you're going to get 356,000. All right, let me give you another one. So number 2 is 6.8 times 10 to the negative 4. And so this time we're going to move the decimal 4 places left, because multiplying 6.8 by 10 to the negative 4 power is going to make us smaller. And so we're moving our decimal left. So let's write 6.8. Let's put some zeros in, and we need to go 4 to the left. So that's going to be 3 zeros and a 6/8. All right, so now we're going to go the other direction, convert to scientific notation. So number 3, 329 million. That's actually the number of people estimated in the United States. So let's write that in scientific notation. So remember, we need a number between 1 and 10, 1 digit left of the decimal. Currently, our decimal is right there. So we're going to have to move left. Let's see, that's going to be 3, 6, 7, 8 places. And so it's going to be 3.29 times 10 to, now we got to decide, is it to the 8th power or the negative 8? Well, 3.29 times 10 to the positive 8 would make us bigger, which is what we need, and so it is going to be 8. So you can reason it out. In fact, you can go in reverse to check yourself, but you want to make sure that you're going the right direction using the right sign on your power of 10. Okay, on number 4, we've got 0.0821, or 821 ten-thousandths. And so, let's see, we need to move that decimal so that we have a number with 1 decimal left, or 1 digit left of the decimal. So let's move it to the right of the 8, between the 8 and the 2, and that's going to be 8.21. Now we moved the decimal twice, and so we're going to use a 2. We just have to decide, is it positive 2 or negative 2? Well, multiplying 8.21 times 10 to a positive power would make us bigger. That's not what we need. We need to multiply by a negative power so that we're getting smaller, because 0.0821 is smaller than 8.21. So it's going to be negative 2. So again, you can always go in reverse to double check yourself. This is usually the harder direction for students to go. All right, let's move on. What if I say multiply and I give, we're going to write our answer in scientific notation. And so we have 3.4 times 10 to the 5th power times 5.2 times 10 cubed. So we're going to multiply these out, and we're going to write our answer in scientific notation. So notice with multiplication, we know we can multiply in whatever order we want. Let's multiply the 3.4 and the 5.2, and we'll multiply our powers of 10. And so 3.4 times 5.2, you can check that, that's 17.68. And we multiply powers that have the same base, we just add the exponents, and so that's going to be 10 to the 8th. The only problem is, notice that this first number is not in the correct form. It doesn't have one digit left of the decimal. It's not a number between 1 and 10. So we need to fix that. So if we move the decimal 1 to the left, we would have 1.768. Now we basically made that number smaller. To balance, we really divided by 10 is what we did. And so we need to make the other number bigger, basically by multiplying by 10 and increasing the exponent to a 9. So if I make this value smaller, I need to make this value bigger. So that's one way to think of it. The other way you could do it is you could rewrite 17.68 in scientific notation. It would be 1.768 times 10 to the first power. And then multiply that by the 10 to the 8th power. Again, when we multiply powers of 10, we'll add the exponents, and we get the same answer that we had before. All right, so let's move on to the next problem. Here we're going to divide and write our answer using decimal notation, or sometimes we call it standard notation. That's the way that we write our numbers. And so 2 times 10 to the 5th over 3.2 times 10 to the negative 2 power. So I would say, since we need to give our answer in decimal notation, I would just put this into the calculator and make sure you use parentheses. And when you do that, you get 6,250,000. Now you could actually do this by hand. You could break this into two fractions. Remember, you multiply across when you multiply, so this is still equal to what we started with, 2 times 10 to the 5th over 3.2 times 10 to the negative 2. But now we can divide this part, and we get 0.625, and I also divided here, and you subtract the exponents. You do 5 minus negative 2, and that's where I get the 10 to the 7th. And again, I could change this to decimal or scientific notation, but they wanted decimal notation, so we just multiply and we get the same thing. So again, I would just put this into the calculator directly, and that would be fine. I guess I did a little bit more there. So application. Let's do one application. You'll have a couple in the homework. So if the national debt is $22 trillion, which it currently is about that, and the population of the United States is 329 million, how much does each person in the U.S. need to pay off the national debt? Wouldn't that be awesome if we didn't have any debt? So we said there's 22 trillion dollars owed. So we need to write that. Let's go ahead and write that first in standard form. That's 22,000, 22 million, 22 billion, 22 trillion. Man, 12 zeros. And if we change that to a scientific notation, we're going to have to move that decimal 13 times. You can count it. We're starting here, and we're going to have to go 13 times to the left, so it's 2.2 times 10 to the 13th power. If we write 329 million in scientific notation, let's see, we're going to have to go 3, 6, 7, 8 times. So it'll be 3.29 times 10 to the 8th. So now what we basically want to do is divide up that 22 trillion into 329 million parts. That's a division problem. So we'll divide the 22 trillion by the 329 million. And if you put that in your calculator, you get $66,869.30. So for every man, woman, and child, if you would just pay your part, $66,869.30, we could get this thing paid off. I think we should try to do it next week. And that's all I have for you guys. We'll talk to you later. Bye-bye.